So students, here we have this rigid body, and this is our origin O. This is xy plane, and the parallel to xy plane is x dash y dash plane, and along this plane I have a particle P, and at time t is equals to 0, the position of the particle was here, P naught. So already at an angle theta naught, okay, and then in time delta t it moves from P naught to P, and this now the angle is theta, okay. So how much the angular displacement? This much is your angular displacement in time delta t, and that angular displacement is delta theta, okay. So here but the body was at origin and it was at position x naught at time t is equals to 0, and in time delta t this body moves to x, position x. So what's our displacement here? Here our displacement delta x is equals to, this is your x and this is your x naught. So displacement is x minus x naught. So, and what is delta t? You can write delta t as time t minus t naught is 0 here, so you can write it as t. And some of the time we denote like delta x as final position minus initial position also, like x2 minus x1 also, if you are denoting initial position as x1 and final position as x2. So we write this as delta x also. And similarly, if you want to write it in terms of position vector, then displacement is equals to r2 minus r1. You can further write it as reaching r2 from r1. Write it as this also, this way also. So these are the many ways how you write displacement, okay. And further final position you want to write from x2 is equals to x1 plus delta x. So that's how you write it, that in terms of position vector, this is r1, this is final means the body was here r1, this is the point, suppose p naught means, and this is at p, position at p, and this is the position vector r1, position vector r2, and this is the this is delta r position vector, and this is what delta r is, because here you can clearly see by triangle law that r2 is equals to r1 plus r2. So that's how we write the final position. The final position is equals to initial position plus displacement. So these are all ways how we write the displacement. Now let us see, so similar way we write the angular displacement also. So angular displacement is here is delta theta, and that is equals to theta minus theta naught. So that's our angular displacement, okay. And the next thing is after the displacement we have velocity. So what is velocity? Velocity is equals to dx by dt, or average velocity we can write as delta x by delta t, and instantaneous velocity as dx by dt. So here also same thing, but the symbol is different. Means instead of v, so we are changing v with omega, and omega equals to d theta by dt. So replacing x with theta. So here there was change in position, here there is change in angular position. Okay, now the next thing is, and here we are not writing even this omega in, we can write it in vector form, okay, but if motion is straight line, we don't need it in vector form. So similarly here, as the fixed axis you have, so in fixed axis, like in motion in straight line, in fixed axis you don't need the vectors. And then we have next term is acceleration. So here we have velocity, here we have angular velocity, and here we have acceleration, average acceleration, change in velocity upon change in time, and instantaneous acceleration as dv by dt. Same is the case here. Instantaneous acceleration is denoted by alpha, so A is replaced with alpha, and we know that v is linear velocity is replaced with angular velocity. So this angular acceleration alpha, and that is equals to d omega by dt. So that's what angular acceleration is. Okay, now next step is to derive the three equations of motion. So equations of motion for constant acceleration using calculus method. We also call it first principle method. See there are three methods to derive the equations. First is graphical method that you started learning from class 11th, class 9. Second one is algebraic method. We did it in chapter number 3, and there was one more method in chapter number 3, that was this calculus method. So there are three ways to derive the equations. So here also we'll derive the equations of angular rotational motion. We'll derive the three equations using calculus method or first principle. Okay, let us see how we did it in so what are the three equations of motion? V is equals to u plus at, and the next one is S is equals to ut plus half at square, and the third one was V square is equals to u square plus 2as, right? So similarly here we'll have three equations. So you know that in rotational motion we replace x with theta, we replace okay, now how shall we write it? One more way to write it as like v is equals to v naught plus at. And what is displacement? Displacement, I told you that this you can write it as if the position is at this S is delta x, So you can write it as x minus x naught is equals to ut plus half at square, and further you can write it as x is equals to, means the final position. So this is the displacement, okay, and this is x is final position. So the final position, this was your initial position, so the final position is equals to x naught initial position plus displacement, right? And what's your displacement? Ut plus half at square. So initial position plus displacement. So taking this negative sign, this will, so these are the three ways how you can write it. So here also replacing u naught with u with v naught, so v square minus v naught square plus 2a, and replacing s displacement with x minus x naught. Okay, now here replacing x with x naught, and so this x is replaced with x naught, and what's x naught replaced with? X naught is replaced with theta naught. Now you have v and v naught, so v naught is replaced with omega naught, and v is replaced with omega. So simply means like these knots, wherever you have knot like this or this is at time t is equals to 0, and these means x and theta, v and omega, this is so these are at time t, and these ones, this one, this is at time t, and the knot is for t is equals to 0 everywhere. Okay, now what else? A is replaced with alpha. Time remains the same variable in both the cases. So how can we rewrite these equations? Means they're analogous equations. Let us start with this one. First one, omega is equals to omega naught plus alpha t, and theta is equals to theta naught plus omega naught t plus half alpha t square. Then we have omega square is equals to omega naught square plus 2a into theta minus, instead of a there will be alpha. So these are the three equations of motion. See, graphical method is the easiest one, algebraic is also easy, calculus is also easy. So all the methods are easy, but calculus is a new one for you. So, and we'll see why it is advantageous that we need calculus method. What is the advantage of calculus method? I will also discuss it. So suppose this is the first equation of motion that we are going to derive. Okay, so we'll be deriving all the three equations of motion. Now students, we have the formula A is equals to dv by dt. Okay, so acceleration means instantaneous acceleration is rate of change of velocity. Now we can further rewrite this equation as dv is equals to a dt, and now we can integrate it both sides with respect to already given here dv. So students, integrating with limits, so change in velocity, so where the velocity was changed, total change, I am adding the whole change in velocity. Okay, adding up the whole change. So where the velocity started with, the velocity was started with v naught was the initial velocity and v is the final velocity. So I got the whole velocity. Okay, here it was at a particular instant, and the instantaneous acceleration, but okay. Now the whole displacement, I am talking about whole journey from this point t0 to t, or you can say v0 to v, and what, so here time t0 time was 0, t is equals to 0 here, okay. So t is equals to 0 to time t, because here I have dt, so I need to put the limits of time. Here it was change in velocity, so I need to put the units, means the limits of velocity, but the time was 0 when the velocity was v0, time was t when the velocity was v. So both things you need to check. First thing is the limits according to this change. So here it was dv, so limits initial and final change. Now here according to t, 0 to t, first thing. Second thing is cross check it. When the time was 0, velocity was v0. When the time was t, velocity was v. Now this is a into dt. And acceleration is constant. So see, we have like from here we have two ways. One, acceleration is constant, and another, acceleration is not constant. So if acceleration is not constant, suppose acceleration depends on t, so acceleration you will be writing as suppose 2t square. So put the value of acceleration here as 2t square, okay, and then do the integration. But if a is constant, so that's not the part of our syllabus, but that is the advantage of deriving the equations of motion with calculus, that you have the way to derive them if the acceleration is not constant. So what is the advantage of using the calculus method? The advantage of using the calculus method is that we can derive the equations of motion and use them for even when the acceleration is non-uniform, okay. But when the acceleration is uniform, so it is constant, so you can take it outside. So what do you get? And what's this integration of dv? Integration of dv is v, and then limits v0 to v, and here that is equals to a is constant, will come outside, and what is the integration of dt? That is t, and this is 0 to t, okay. So this we are not taking this case when a is non-uniform. Now this final value, put v is equals to v minus v is equals to v0. So v minus v0 is equals to a into, put t is equals to t minus t is equals to 0. So that's what we get. So we get v is equals to v0 plus at. So we have derived the first equation of motion. Now what is the second equation of motion? That is this equation, x equals to x0 plus ut plus, so instead of ut we will be writing here v0t, okay. So v0t plus half at square. Now see what we did here. Here we started with a is equals to dv by dt, because I need to put the limits. I need v and v0. So how can you get v and v0? Definitely you need to put these limits. So from here only you get the hint that you need to do the integration, because that is the only way, students, to get v and v0. Integrating dv with the limits v and v0. So definitely you are going to start with something with dv. So that's the hint you get from here, and especially this is v minus v0. So you get the hint from here that we need the formula which contains dv. Now what is the hint that you got here? What do you need? Here you need v and v naught. Here you need x and x naught. And definitely this is x minus x naught is equals to v naught t plus half at square. So tell me, you need a formula which contains dx. So which formula contains dx? Tell me. Which formula contains d? Yes, very good. So v is equals to dx by dt. So students, it's so easy. I was telling you that all the three methods are easy, but the calculus one is we derive the equations for non-uniform acceleration also. And it's, see how easy it is. Okay. Now v is equals to, now it's so simple. Same manner you will do it. So here you will get dx is equals to, you can rewrite as dx is equals to v dt, and then you will be taking the limits x naught to x and time t is equals to 0 to t. Now the difference only here is, here a was constant and here v is not constant. So if v is not constant, like here, if a was not constant, I need to put the value of a here, right? But if a is constant, then a came out. But here v is not constant, so put the value of v. What is the value of v? This is the value of v, v naught plus at. So, and what do I get this side? This is x and this is x naught x. This is equals to, now put the value of v. So 0 to t, this is v naught plus at into dt. Is it okay, students? Now this comes out to be x minus x naught, and this is equals to, now distributive law, so 0 to t v naught dt plus 0 to t at into dt. Now here it will remain the same. What do you get here? That's equals to, so v naught is constant, v naught will come outside, and that's your integration of dt is t 0 to t plus, what do you get here? A is constant, so a will come outside. And what is the integration of t? So integration of t here that we are left with, so that's equals to v naught, the t is equals to t, so t minus 0 and plus a into, what is integration of t? So integration of t is, yes, what is the integration of x into dx? What is the integration? xn, suppose here I have xn, so then it is xn plus 1 divided by n plus 1. Okay, so here the power is 1, so power n plus 1, 1 plus 1 is 2 divided by 2, 0 to t. Okay, and this comes out to be v naught t plus a into, put t is equals to t, so that's t square by 2, that's 1 by 2 t square by 2, and put t is equals to 0, so 0 by 2 is 0 and multiply by, means it will be 0. So even we need not to multiply, we are multiplying with t. So this is simply that with so t square by 2, limit t to 0, put t is equals to t first, final value, minus put t is equals to 0, so 0 square upon 2, and that's equals to t square by 2 minus 0, that is equals to t square by 2. So students, so that's how we get x minus x naught. So that's your displacement, and if you want to write it in terms of final position, this x naught minus will become positive, v naught t plus half at square. Okay, and now we have third equation of motion. What is the third equation of motion? That is v square is equals to v naught square plus 2a x minus x naught. Now the key thing here is, students, that you can clearly see you need v and v naught, and you need x and x naught, right? So here you will be needing only v and v naught, here x and x naught. So here definitely you need this side, you need dv, and so can you visualize it, that this side you need, like here you need to put this value. Suppose here this is v square, so you need v square here, right? So you need definitely you need v dv, then only like t dt, then only you get t square by 2, and this 2 this side becomes null. So this definitely you are going to need v square minus v naught square is equals to 2a x minus x naught. So here you need dv, right? And this side you need dx. Agreed or not agreed?
Yes, sir.
So how do you get an equation which contains both dv and dx? So let us see. You have a equals to acceleration is dv by dt, okay? Because if you need dv, definitely you need acceleration. You can't get change in velocity without acceleration, right? So this is the hint I get from here, okay? Let me just remove this thing. Okay, students, I hope you are understanding why we are using particular formulas. Now you got the dv, but you need dx also. So how can you get dx? So that's all right, that a is equals to dv by dt. But how do you get dx? So this we can, this formula we can further rewrite as chain rule. So that's dx by dt. So students, this is chain rule. We do it in differentiation. When we'll learn differentiation, we use, this is one of the rules, chain rule, okay? So now you have dv also and you have dx also, okay? Now, but I don't need dt. Do you need dt? Huh?
No, sir.
No. So you need to remove this dt. So how shall we writing this? So I don't need dx 2 times. I need just dx 1 time, and I need dv also 1 time. So I need to get rid of dt as well as this extra dx, and I know the formula, that what is dx by dt? Yes, what is dx by dt? That is v, velocity. Okay, so I have get rid of both of them, and I told you that I need v into dv, because like here t into dt, then only I can get t square by 2, right? And this 2 will go other side. So see students, this equation is shaping up. So I will get v into dv is equals to a into dx. Now you can clearly see that I get this answer. Like a is constant will come outside, and this, right? So now let us do the integration both sides. What are the limits of dv? Yes, tell me. V naught to v. What are the limits of x? X naught to
X naught to X.
x, right? Now what do I get here? V dv. So integration of v is v square by 2, and the limits v naught to v, and here the a is constant, a will come outside, and what is the integration of dx? Dx is x, and x naught to x. Okay, and here what do I get now? Put the value of v is equals to v. So half is constant, I can write it even outside, and put v is equals to v, so v square minus, put v is equals to v naught, so that's v naught square, and that's equals to, now put x equals to x, final value, minus put x equals to x naught. So that's how I got it. Now 2 will go that side, so just forget this thing. So v square minus v naught square is equals to 2a x minus x. Students, you can see that's the beauty of physics. There are n number of ways to tell a particular thing, and definitely we are going to need these ways. They have their own advantages. Like even you have seen that in how many ways I have written the displacement over here, right? And like equations of motion, this equation of motion particularly, see in 3 ways we write it, like in terms of displacement in terms of x, then displacement in terms of delta x, and then in terms of final position, right? So a lot of ways we have written this equation. So that's in terms of, this is displacement is equals to x minus x naught. So this is in terms of displacement, these 2 equations, and this is in terms of final position. And now you can see how you can use the calculus. If the a is not constant, uniform, then you will get some other equation, you can derive it. So this variable in terms of t, acceleration will be in terms of t, and you will have new velocity, and that you will put here, so this will also be changed. And here acceleration, again you can not take it outside, but you put the value of a here. So you can use this calculus method for non-uniform acceleration also. And the last thing, how to derive it, you get the hint from here. V and v naught, you need dv only, right? And you need t, so dt result, you know, the 0 to t, it will give you t only. Now here you need x minus x naught, so you can get x minus x naught only if you have dx, right? And then you started with this formula, and here you need v and v naught and x naught, so you need both of them, dv as well as dx. So we started with dv, only choice we have is acceleration is equal to dv by dt, and then this is the chain rule. By chain rule we have rewritten this formula, that's equals to, so dx is now this is equals to dv by dx, and what is dx by dt? That's instantaneous velocity. And then we further taking the integrating both sides with the limits, and we have derived these formulas. So students, that was simply revision of and little bit of angular displacement, means angular rotation variables we have studied. So similar equations we will have in, like we have written the equations here, so similar equations we have, and in similar way, see, absolutely in similar way, you just need to replace these variables. Okay, just need to replace these variables, and in exactly the same way, because you need to just replace the variables. Like here you need to replace v with omega, v naught with omega naught, a with alpha, and x with theta, x naught with theta naught, and you can derive these equations in the same way, so that's homework for you. So derive them using the first principle in the same way as we have derived them. Just you need to replace the variables, nothing else. But first equation, let us see one more way how to derive it, one more aspect. Okay, so this is omega naught to omega. This is how we first equation I am deriving for you. That is your omega is equals to omega naught plus alpha t. So definitely you are going to need the formula of you need d omega. So d omega is equals to alpha dt, and integrating both sides 0 to t. So from here I get omega minus omega naught, and from here I get alpha t, and that's equals to this equation. So omega is equals to omega naught plus alpha t. Now let us see this was I was using definite integral over here. Okay, I was using definite integral over here. Definite integral means the integral with the limits. Okay, so that's definite integral. Now let us derive it using indefinite integral without limits. This is the new thing for you students. Okay, now same formula, alpha is equals to d omega by dt, and same thing here, d omega, so d omega is equals to alpha dt, and taking integration both sides. But here I am not taking it with limits, so no limits. Okay, now what is the integration of d omega? That's omega plus, what's the difference here? So here the integration was omega, right? And here we were writing the limits, right? But here we are not writing the limits, so we need to write here constant of integration. That's the difference. Okay, so we can write it constant of integration 1. In this side also we will have constant of integration, and alpha was constant, so it was and integration of dt was t and 0 to t. So here also alpha is constant, so integration of dt, and so omega plus constant of integration, I can write it as c1 also, and this alpha, what is the integration of dt? That's t. Okay, so but now here I need to write the constant of integration. So if in case of indefinite integral, I need to write the constant of integration. So constant of integration is, let it be c2. Okay, so now omega is equals to alpha t plus this minus c1 will become this side, so you will say such alpha c2 minus c1. Okay, so alpha is also constant, c2 is also constant, so you will get a constant here minus c1. Okay, so constant minus constant is again a constant, so this is the ultimate constant. So students, you need I have just explained you this concept. You need not to write this COI1, C1, C2. You can simply write this thing. Okay, right from this thing you can simply write this thing. D omega, you know that it's omega, and alpha is constant, and integration of dt is t. So these two are extra steps just to explain the concept of constant of integration. So now omega is equals to but this is the so you need to remove this. You need to remove this c. So you need to find this value of c. How do you remove it? You find the value of c. So how can you find the value of c? So you can find the value of c if you remove this term. So c will be equals to this. How can you remove this term? By putting t is equals to 0. So so if t is equals to 0, you need to put t is equals to 0. So if t is equals to 0, what will be the value of omega? So if t is equals to 0, then omega is equals to omega naught. So put the value of t and omega here in this equation 1, suppose. So from first, put omega is equals to omega naught is equals to, put t is equals to 0, so this is 0 plus c. So you get c is equals to omega naught. So put this value of c equals to omega naught. Students, this is very important way, because I am telling you that we want to prepare you to study physics in the higher classes. So that's why this is one of the ways, very important way. So learn it, okay, understand it. So c is equals to so from first again put c is equals to omega naught in equation first. We get omega is equals to alpha t plus omega naught. Okay, so you get omega is equals to, like here you get you have the in linear v is equals to u plus at, v is equals to v naught plus at, and here you have omega is equals to omega naught plus alpha t. So students, today you have learned all the ways how calculus can be used in different ways to derive these equations, and I have derived the first equation in both the ways. So I hope you can do it now. The last thing that we need to do today is the units of angular velocity. So units of angular velocity. Now that, like this angle theta, so, and the body is rotating, the particle is rotating in the circle, and this is the displacement, suppose delta theta. Now what is angular velocity at a particular instant? Suppose at this instant, so that's equals to d theta by dt. So or average, you can write delta theta by delta t. So what are the units of theta? Units of theta is radians and time second. So these are the SI units, radians per second. But the another unit of omega that you find in the common units that we use is revolutions per second. So like this is 1 revolution. So revolution per second. So it's very important. So like the units can be revolution per second also. Okay, so this is how you get in your questions, revolution per second. So you need to change revolution per second to radian per second. Okay, so second is there in both the cases. The only thing is what is the relation between revolution and radian. So if you have, suppose, 10 revolution per second, how will you change it into radians? So simply write it as 10 into, how much is 1 revolution? 1 revolution means 1 round. 1 round is 2 pi radians. Yes, 360 degree, that's equals to 2 pi radian, 1 revolution. So 2 pi radians, RAD, divided by second. Changed. It's as simple as this. So we can simply change it like this, revolution per second to radians per second. Now another important formula we derive from here, that omega is equals to delta theta by dt. So if for 1 revolution the angle is 2 pi radian. Okay, so how much is the time for 1 revolution? For 2 pi radian, the time is, we call it time period. Time taken for 1 revolution is capital T. This is time period for 1 revolution, that I call time period. So another formula I have got. So this is the angular velocity, right? Now I need to write this angular velocity in terms of angular frequency. So if I write it in terms of frequency, so what is 1 by t? 1 by t is your frequency. So that's equals to 2 pi nu. So that's so this is the formula for angular velocity. angular velocity. When I am writing it in terms of change in angle, okay, but when I am writing it in terms of frequency, then it becomes angular frequency. So that's all for today, students. Thank you for being with me.